Good evening everyone. My name is Kiran. I teach chemistry at Gosala. So today we will be taking up the topic of quantum numbers. See, what is quantum numbers? See, actually this is a very important topic which comes in the chapter of atomic structure. And you will learn this topic again when you come here when formal track begins. At that time you will again learn this topic towards the end of the atomic structure chapter, and this topic is very important because after learning this topic you will be able to write electronic configurations of the elements, and using that electronic configurations you will learn various trends across the elements in periodic table, atomic size, when it is changing, why it is changing like that, ionization energy, electron affinity, all these topics in other chapters you will understand only when you have knowledge of writing electronic configuration. So this is a very basic concept. Now see, these quantum numbers are actually derived from a mathematical function called wave function. See, it's a very complicated function. Wave function is very big and very complicated mathematical function. But based on that mathematical function only, scientists have derived these quantum numbers. And to give you easily or to make you understand easily, I will tell one analogy. Suppose if I go to a courier center and if I want to send a courier to my family, definitely that person will ask me to write the address on the top of that courier. Suppose if I write Aadhaar number of my, suppose if I want to send courier to my brother, if I write the Aadhaar number of my brother and if I give that courier to that person, will he able to accept that? Definitely no. Of course, that Aadhaar number is unique for every person. Okay, so that Aadhaar number contains all details. It contains the name of the person, age, and house number in which that person is living, street, city in which that house is present, everything, all information is present in the Aadhaar number. I mean, that is a unique for every person. One can derive everything from that. But just by writing that number on the courier, will that person of courier office identify what is the address and name of that person or house number? No. He will ask me to write, okay, strike it off and write properly what is the name, house number, street and city, everything properly. In the same manner, remember here in case of atom, this Aadhaar number of electron is nothing but this wave function. Wave function is like Aadhaar number. Okay, it is similar to, okay. So it is like Aadhaar number of the electron, and it is very complicated function. It is a very big function and very complicated. So it is not easy for us to understand that mathematical function. Actually it holds all the information about electron, like how Aadhaar number holds all the information about the human being, same way it is present, all the information about the electron. But for us it is difficult to comprehend, understand and extract the information from that. So to understand about information about electron easily, we devised a new concept called quantum numbers. So this is a concept for human beings to understand the information about electron. Okay. Now there are 4 quantum numbers are there in this concept of quantum numbers. One is principal quantum number, Azimuthal quantum number, magnetic quantum number and spin quantum number. These are the 4 quantum numbers. Now just like in that analogy which I told you earlier, so when you write the address, what you will write? You will write the city name in which that person is living, and above that street, above that you will write house number, and above that you will write the name of the person. Then only that courier person will accept and send that courier to the respective place. Now it is similar to, in our case of electron, city is like principal quantum number, and street is like what? Street is like Azimuthal quantum number. House number is like here magnetic quantum number, and finally name, it is like spin quantum number. So if you mention these 4, then only you are specifying which electron you are talking about inside an atom. Okay. It is an analogy. Don't think that, okay, if you go into atom and if you see there is a city will be there, in that street will be there. It is not like that. But for us, for humans to comprehend information about the electron, we visualize or we devise the concept in this way. Okay. I hope every one of you understood this concept, what these quantum numbers are about. Now we will go in detail each one. Principal quantum number. Now see, principal, azimuthal and magnetic. First let us understand these three. Spin quantum number we will understand later on. Principal quantum number. It is also called shell number. Is like city, na? It is an analogy, like analogy of this one is city, okay, and azimuthal is analogy is street number. So, and in this terminology is principal quantum number means it is a shell number of the electron, whereas azimuthal quantum number, it is called subshell number. For our visualization, we treat it as a street, city, street, house number. But here technical terms is, actually speaking, technical terms are shell number, this is subshell number, and inside that subshell, orbital. This is the orbital number, or in other words house number if you visualize. So in that house or in that orbital actually electrons will be present. Now, shell numbers, we will call them as first shell, second shell, third shell, fourth shell, like that. If n is equal to 1, principal quantum number 1, we say it is a first shell, 2 means second shell, 3 means third shell. Now, azimuthal quantum number or subshell number. Now here subshell numbers, they depend upon the shell numbers. The values of subshell numbers depend upon which one? Shell numbers. How it will depend? This L values or azimuthal quantum number values begin with 0. Begin with 0 and they will go up to n minus 1. So last value of azimuthal quantum number. In other words, these are the, let's say, street numbers. Okay. So last street number in that city will be what? That number depends upon the n value. For example, n is equal to 1, first shell. So first shell you have to begin with 0, and what is the last number in that? N minus 1. N minus 1 will be 1 minus 1, again 0 only. So that's why there is only one subshell exist in this, not more than that, only one exists. 0 and ending is also 0 only. Next, second shell let's take. In second shell, so how many subshells will be there? Subshell starts from 0 and end with n minus 1. So 0 I have started, this is the first subshell number here, and next is 1, and n minus 1 will be what? Calculate n minus 1. N minus 1 will be here 2 minus 1, which is 1. That means the last number of azimuthal quantum number, subshell numbers, last one will be 1 only here. That's why 0 is the beginning, 1 is the ending. Don't go beyond that, don't go beyond 1. 2 will not exist here, only 2 subshells only exist. Now come to the shell number 3. In shell number 3, what is the n minus 1 value here? 3 minus 1, that means 2. That means last value of subshell has to be 2. Beginning value has to be 0. So 0 up to 2. So 0, 1, 2. So 3 subshell values exist. If you take n is equal to 4, then last number has to be 3. N minus 1 will be 3. Then if n is equal to 4 will have what subshell values? 0, 1, 2, 3. Like that. In other words, these are the street numbers. Okay. I told you to visualize like a street numbers. So third city, in third city, how many streets will be there? Only 3 streets will be there. Okay. In each street, houses will be there. That will come later on, but how many streets will be there in that particular city? 3 streets, like that. Now let's come to the house numbers. In a street, houses will be there, okay, and here we call them technically orbitals. In a shell, subshell, in a subshell, orbitals. Now like how subshell numbers depend upon the shell numbers, same way these orbital numbers depend upon the quantum number. Magnetic quantum number depends upon the azimuthal quantum number. Now its notation is magnetic quantum number is ml, and those ml values, I hope it is visible. If it is not visible, I will change the color. Let's take white one only. ml values depend upon the L values. See how it starts from minus L, goes to plus L. The beginning will be minus L and keep going and increase one value of 1 and go incrementally, and last number will be plus L. Means what? See, if I take L is equal to 0, minus 0 you begin and end with plus 0. Minus 0 plus 0 means 0 only. There is nothing between them. So ml value will be only 0. Only one orbital will exist in this subshell. In other words, only one house will exist in this street. Only one house will exist in this particular street, like that. Next, now come to the second city. Second city means second shell. In that shell, how many streets are there, or how many subshells are there? 2 subshells, 2 streets. Now let's come to the first street. First street, let's come. Now in that street or subshell, how many will be there in that street? Since L value is 0, minus 0 to plus 0 means 0 only. So only one house will exist, one orbital will exist in that particular street or subshell. And that orbital value will be, magnetic quantum number value is 0. Now let's come to the second street, that means second subshell. Now in that value is what? L value 1. So orbitals values or magnetic quantum number values begins with minus L and ends with plus L. So let's follow that rule. So minus L means what? Minus 1 is the beginning number. Next comes what? Next number after minus 1 is 0. Then after that next number will be 1. So minus L value to plus L value you take. Don't go beyond 1, because here L value is 1. So you start with minus 1 and final value has to be plus 1. Don't cross that plus 1 value. So total how many orbitals will be there? 3 orbitals will be there, and their values, orbital numbers, or you can say magnetic quantum numbers of that orbitals will be minus 1, 0, 1. Next come to the L is equal to 0. L is equal to 0. Now here in this N is equal to third, N is equal to 3. In that particular city or shell, how many subshells exist? 0, 1, 2. 3 subshells exist in that. Now in that each subshell, let's find out how many orbitals exist or how many magnetic quantum numbers exist. See, in 0, again 0 only, minus 0 to plus 0 means 0 only. In 1, minus L to plus L means minus 1 up to plus 1. So 3 orbitals will exist in that subshell 1. In that second subshell, how many will exist? Again follow the same rule, minus L to plus L. So minus L is what? Minus 2 is the beginning number, minus 2. So minus 2, minus 1, next comes 0. After 0, what is the next number? Positive number. So 1, 2. Stop here, because minus L value up to plus L value only we have to take, not beyond that. So these are the numbers here, magnetic quantum numbers. So how many houses are there here? So each one represents, imagine each one is like a house number. Okay, each number is a house number of particular house. So how many such houses exist? How many numbers exist? You count 1, 2, 3, 4, 5. 5 numbers are there. So 5 houses are there, or in other words 5 orbitals are there. That is the technical word we use. We don't use the word house. Okay, in the electron point of view, we use the words, technical words here, orbital. How many orbitals? 5 orbitals are there. In which street? Again, we don't use this word street actually. We use the word subshell. In which subshell? Second subshell. In which city? That means in which shell? That is the third shell. So this is how the magnetic quantum number, azimuthal and principal quantum numbers are defined. Now, let's go to the fourth quantum number. I hope all these 3 quantum numbers, you got some idea about them. And let's now go to the fourth quantum number, which is spin quantum number. Now, in the earlier page, I gave you analogy. That is what principal quantum number is like city, azimuthal, street, magnetic quantum number is like house number. Spin quantum number, it is, what is its analogy? It is a name of the person. Okay, particular person. Who is that person living in that house? When you write address, you have to mention the name. In the house, maybe 2-3 people are living. To which one you are sending that courier? So you need to write that name. Similarly, in that orbital, which electron you are talking, you have to mention. That is the spin quantum number. It talks about particular electron in that orbital. Now, any electron present in an atom has either of the below 2 spins. So orbital is like a house. Okay, in that house, actually only 2 electrons are present. Okay, maximum 2 electrons. So these 2 electrons, either of the 2 spins they will be having clockwise spin, anti-clockwise spin. Okay, any electron in an atom, you take any electron, they have a spin. Okay, like how Earth is moving clockwise and Earth is moving rotating on its own axis. Same way, here electron has its own spin. One is called clockwise spin. If it is moving in anti-clockwise, we say it is anti-clockwise spin. Now, so any electron present in an atom has either of these 2 spins, either clockwise or anti-clockwise. Now, spin quantum number is related to the spin direction of electron. So, spin quantum number, actually it is related to what? Spin direction. It is moving in clockwise or anti-clockwise spin. It is talking about that spin quantum number. If electron has clockwise spin, if it is moving in clockwise direction in its own axis, then the spin quantum number will be plus 1 by 2. Plus 1 by 2 is the spin quantum number allotted for such electrons having clockwise spin. If electron has an anti-clockwise spin, clockwise means like this, anti-clockwise means this is what clock direction, right? So anti-clockwise means opposite. So anti-clockwise spin, if it is moving, then its spin quantum number is given as minus 1 by 2. So see, azimuthal, principal, magnetic, they can have various numbers, but spin quantum number has only 2 values, minus 1 by 2 plus 1 by 2. If electron is having clockwise spin, plus 1 by 2, anti-clockwise minus 1 by 2. That's it. Within an orbital means within a house. Orbital is like house, I said. So within a house, there exist only 2 electrons. In normal house, there can be any number of people living. Okay, 2, 3, 4, 5. But here in an atom, in any house you take, orbital you take, maximum people, maximum occupants in a house will be only 2. That means maximum 2 electrons only present in any orbital inside any atom. And with spin quantum numbers, maximum 2 electrons will fit, and their quantum numbers are what? Plus 1 by 2 and minus 1 by 2. It's like male, female, only 2 people will be present in the orbital, and one is clockwise, other is anti-clockwise, like that. Next. Now, so earlier we have seen this principal quantum number, azimuthal quantum number and magnetic quantum number. Okay, and their values also we have seen. And here I will mention one more point, that is, see, there is alphabetical notation also given to these numbers. See, n is equal to 1. N is equal to 1. Alphabetical notation is K. first shell, when we say first shell, it is also called as K shell. K means here 1. L means second shell, M third shell, N fourth shell, O, like that shell numbers are given. K means first shell, L means second shell, likewise. Similarly, alphabetical notations are given for this azimuthal quantum numbers also. Let's see what are they. 0 means S. Okay, 0 means S. 0, L is equal to 0 subshell means S subshell, we can also say. So 0 means S. 1 means P. 1 means P subshell. Again S, P, and L is equal to means D subshell. So 0, L is equal to 0 means S subshell, 1 means P subshell, 2 means D subshell. 3 means F subshell. So far whatever elements we are having, only F subshell is the last. Okay, if any new elements are discovered in future, then we may go to other alphabets, G, H, like that, but as of now only 4 subshells we deal with any element in the periodic table. S means L is equal to 0, P, L is equal to 1, D, L is equal to 2, F, L is equal to 3. Only these 4 subshells we deal as of now. And for these magnetic quantum numbers there is no alphabetical notations and all, just they are just numbers only. Okay. Now number of subshells within a shell. Now look here in this list, in this table, okay, if you take first shell means K shell. In that K shell, how many subshells are there? Only 1 is there. First shell you have taken, in that first shell only 1 subshell is there. If you take second shell, see N is equal to 2, in that second shell how many subshells are there or how many streets are there? Only 2 streets or 2 subshells are there in the second shell. So 1 subshell in the first shell, 2 subshells in the second shell, and third if you come 3 subshells are there in the third shell. That means whatever the N value is there, that many subshells will be there in that particular shell. That's why the formula is number of subshells within a shell is how many? N value. If I say fifth shell, in that fifth shell how many subshells are there? 5. Fourth shell, how many subshells are there? 4. So N value is the number of subshells present in that. Simple. Next, number of orbitals within a subshell. How to find number of orbitals? See, writing like this table one by one and counting all takes time. Okay, what is the formula? What is the easy way? See, number of orbitals within a subshell is 2L plus 1. 2 into L value plus 1. Let's see that, check this out. Now see, suppose if you take a subshell, S subshell means what? L is equal to 0 subshell, let's take. In that subshell, how many orbitals are present? Let's count that. How many orbitals are present? Only 1. Only 1 orbital is present. Let's see whether that formula holds good or not here. Okay. So what is the formula? 2L plus 1. 2L plus 1 means 2 into L is what? L value is what? In the subshell 0. So 2 into 0 plus 1. That is 1. Yes, only 1 subshell only exists. 1 orbital is only existing in that subshell. So formula is correct here. Let's go to the other and also check it out. So L is equal to 0. L is equal to 0 have only one orbital. Yes, we got only 1. Let's take L is equal to 1. In that subshell, how many orbitals are present? Let's count. That means in that street, how many houses are present? Let's count. How many are present? 1, 2, 3. So 3 orbitals are present. Okay. Let's use the formula and see whether you are getting the same number 3 or not. So 2L plus 1 means what? 2 into L value here is what? 1. So 2 into 1 plus 1, which is what? 3. Yes, we got 3 orbitals only in that particular subshell. So we simply got with the formula 2L plus 1 without writing all the value, all the numbers and counting them. We got simply by using the formula how many orbitals are present. Let's take the L is equal to subshell and see whether we are getting the 5 orbitals in that or not. Okay. So what is the 2L plus 1 here? 2 into L is what? 2. In this particular subshell value, L is 2. So total is what then? 5. Yes, count these numbers, you will get 5 only. 1, 2, 3, 4, 5. So 5 orbitals are present in the subshell whose L value is 2. So number of orbitals within a subshell is how many? 2L plus 1. Remember these formulas. Sometimes direct questions are being asked. Okay. In fact, recent NEET exam, on the Sunday exam, this question is asked. One question is asked on this. Okay. Question is asked like this in the recent NEET exam. They have given NM value. NM value is the number of magnetic quantum numbers. The question what they framed is like this. NM is the notation. NM is what they called it as number of magnetic quantum numbers. That means what is actually here number of magnetic quantum numbers is ML. We are calling ML is the quantum numbers. Number of magnetic quantum numbers, they are calling it as NM. And L they are saying value of Azimuthal quantum number. Azimuthal quantum number. Okay. Then which of the following options are right? Like that they have given. Okay. In that, see, if you see number of orbitals means number of magnetic quantum numbers only. Number of magnetic quantum numbers only, number of orbitals, number of houses. So they are saying this one only, they are calling in the question as ML. So, sorry, not ML, NM, they are calling it as in the question NM. So NM is equal to, what is the formula? 2L plus 1. But they have not given the direct formula, NM is equal to L plus 1. They have given in the option like this, one of the 4 options, they have given like this, L is equal to NM minus 1 by 2. If NM is equal to L plus 1, then what is the L value? Bring that plus 1 to the left hand side. NM minus 1 divided by 2 is the L. That is only the answer. Okay. Just they have given these two and asked which is the correct relationship in the options. They have given like this. L is equal to 2 into Nm plus 1. Okay. Nm minus 1 is equal to L. Something like that options, and one of the option which is correct is this one. There. So these formulas are very important. Sometimes you will get direct questions and easy also to remember, not difficult. Next, number of orbitals within a shell. Number of orbitals within a shell. That means, now see, earlier in the second formula what we have studied, number of orbitals or number of magnetic quantum numbers within a subshell we have seen. That means how many houses are present in a street, that we have calculated. Suppose if I ask how many houses are present in that entire city, then a formula will be different now. So let's figure that out. Formula is actually simply n square. What is n? Where n is the shell number. Okay, n is the n value here, and here what we say n is the shell number, principal quantum number. Now let's see that. Suppose if we take third shell, how many orbitals are present? Let's count that all the orbitals, all the houses present in that third city or third shell, count. If you count all of them, here 1 is there, here 3 orbitals are there, here 5 are there. 1 plus 3 plus 5, total 9. 9 orbitals are present in the third shell, which is nothing but 3 square, right? N square. 3 square is 9. So let's again check it for the second shell also, see whether n square formula is valid there or not. So in second shell, how many orbitals are present? Count total. Total orbitals in the second shell will be how many? This is one orbital. Here 3 orbitals. Total 4 orbitals are present in the second shell. So can I simply say 2 square? 2 square is 4. So here also matching. So come to the first shell. First shell has how many orbitals? Only one orbital. So first shell has only one orbital. So 1 square is 1. So shell number, if you know, just square it. You will get the total number of orbitals present in that particular shell. If you know subshell number, how many orbitals present in that subshell number, how do you get? Then that is 2 into L plus 1. That is the formula for number of orbitals within a subshell. Now lastly, number of electrons within a shell. Within a shell, how many maximum number of electrons that can fit? Maximum, okay. Here I have not mentioned that word maximum, but how many maximum electrons that can fit, that can occupy within a shell. Okay, so we know that within any shell, how many orbitals present or how many houses present? Formula is n square. If n square houses are there and each house maximum how many people can present, or how many maximum electrons can be present in a house? I mentioned in the previous slide 2 electrons. One has spin plus half, other has spin minus half. So only maximum 2 electrons can be present within a orbital. So if total houses are, or total orbitals are n square within a shell, then how many electrons will be present? 2 into n square. Because each orbital has maximum 2 electrons, n square orbitals are present, so 2 into n square will be the total number of maximum electrons within a shell. These are the important formulas. Now, I hope you understand all these 4 formulas. Now let's solve some problems based on whatever we have learned so far. First, how many maximum electrons can occupy in all orbitals, okay, in the following quantum numbers. Let's find each option. Each one we have to find separately. These are 4 questions, different questions actually. Okay. Now, third shell, second subshell. In third shell there are many subshells, but they are saying in that second subshell, if you take, suppose in that third shell, if you go to the second subshell, in that subshell how many all orbitals, if you take all orbitals and count the electrons, how many maximum electrons will be present? Okay. So in that second subshell, tell me, in second subshell, that means L is equal to 2, how many orbitals are present? We know the formula 2L plus 1. 2L plus 1 will be the number of orbitals. That means 2 into L value is what? Second subshell means L is equal to 2. So let's substitute that. So total how many? 5 orbitals are present in that subshell. And each orbital has how many maximum electrons can occupy? 2. So therefore, number of maximum electrons in second shell, in second subshell will be, each orbital has 2, total 5 orbitals are present, so answer is 10 electrons. Okay. So now, so that is the answer for the first question, 10 electrons maximum occupy. Let's come to the second question now. Now here they have given only principal quantum number, shell number is only given. So in that shell many subshells will be there, and in each subshell there are many orbitals will be there. In each orbital there will be maximum 2 electrons. So you have to count all of them this time. Okay. So how to find? We know that simply, if n is equal to 4, how many orbitals will be present in that? Total number of orbitals will be present. Number of orbitals will be n square. N square is a simple formula to find all the orbitals in all subshells within a given shell number. So we want all the orbitals here. In the earlier question, we don't want all the orbitals present in shell we don't want, because they have mentioned here subshell, particular subshell. Suppose if I ask you in so and so how many houses are present in Venkateswara Rao colony in Vijayawada, suppose let's say like that. So then you will go to the that colony and you will only count the number of houses, right? You will not count all the houses in the Vijayawada. Okay, that is the first one. First question is, they have mentioned the city, they have mentioned the street also. In that street they are asking how many houses. So 2L plus 1 is the formula. In second question what they are saying, they have given the city. Okay, if I ask you how many houses are present in Hyderabad, this city, they are not mentioning now, this time they are not mentioning the street in that city. So when they say just how many houses are present in Hyderabad, now this time you have to count all houses in all streets. Okay. So that is the formula for it, n square. So 4 means n square will be what? 4 square. 4 square means 16. So total 16 houses or orbitals present. And each orbital, how many maximum electrons? 2. So 16 orbitals present. So maximum electrons will be 16 into 2, 32 electrons. That is the answer for this. Okay. In earlier page we have seen 2n square, that only we are following. Okay. Third one what they are saying, they have given the city name, they have given the street also, they have mentioned. In that street they are saying house numbers +1 -1 only you have to take. Okay. See, suppose if I say in Vijayawada city, in Venkateswara Rao colony, in that house numbers 23, 24. Okay, how many people will be there, like that. Then this time now you don't count all the houses in that street, because house numbers are also mentioned. They are saying go to 23 house number and 24 house number and see how many people are there. So only 2 houses you have to take this time now only. So they have given the city, street, in that they have mentioned only 2 houses. Only 2 houses. And each house maximum how many? 2 electrons. So 2 houses means 4 electrons. So maximum electrons here will be 4, because only 2 houses we have to take, and in that 4 electrons. Next, fourth one, city is given, street number is also given. In that street which house you have to go and look for persons, that is also given. That is one house they have mentioned, house number 0. Okay. So orbital, only one orbital or one house you go, and in that house spin number is also mentioned, name is also mentioned, name of the person is like name of the person. Okay, name is also mentioned. Then how many electrons will have these quantum numbers? Only 1. Okay, so you have given the city, street, house also you have given, and in that house with this name how many persons will exist, they are asking. How many will exist? Only 1 person, 1 electron only exist in that. So here maximum electrons will be 1. So this is one model question which you may get in exams. Okay, I hope you understand this question. I will go to the other one. How many maximum electrons that can occupy an orbital? See the difference between the earlier question and this. You may see, sir, it is like earlier question only, there is a small difference is there. I have underlined that. See, in the earlier question, here what is there? In all orbitals are there. Okay, but now this time what is there? An orbital, one orbital they are talking. This is very important when you are answering questions in exam. Sometimes a single word will change the entire thing. Okay, it will change the answer completely. So be careful when you are writing exams also. You have to read word by word. Okay. So they are saying n is equal to 2, L is equal to 1. In that, how many will be there? It is like this question. I will reframe like this. Suppose if in a Vijayawada, in Venkateswara Rao colony, if you go, how many people will be present in a house? I am not saying in all the houses. In a house, how many people will be present? It is like that. So, in any orbital you take in an atom, no matter what shell or what subshell, any orbital will have maximum how many electrons? 2. So, answer for this is 2. Whether n is n value, L value they have given this or something else, we do not bother. Any orbital in an atom has how many maximum electrons? Only 2. One will have clockwise spin, other will have anti-clockwise spin. Maximum only 2 can fit in an orbital. So, there is a difference between this question and the previous question. Be careful. Next. Now, how many maximum electrons that can occupy all orbitals? This time I am asking all orbitals with n is equal to 2 and L is equal to 1. Okay. Now, you have to find all the orbitals, all the houses present in that subshell, then multiply with 2 to get the electrons. Okay. So, with this subshell, how many orbitals will be present? Number of orbitals is equal to number of orbitals within L is equal to 1 means first subshell. First subshell will be what? 2L plus 1 formula. So, 2 into 1 plus 1. That means total 3. So, maximum electrons how many will be there? 2 into number of orbitals. So, 6 electrons will be there maximum. But earlier question, an orbital is asked, so answer is 2. Here all orbitals. Next, how many maximum electrons that can be filled in all orbitals corresponding to L is equal to 2? See, they have given the street number and they are asking how many maximum electrons within that street. And within the street, we know how to find the number of houses. Multiply with 2 to get the number of electrons. So, it is same as 2 into L plus 1. So, how many orbitals will be present? Number of orbitals within the second subshell is 2 into 2 plus 1, which is 5. So, maximum electrons they are asking in the question. So, each orbital will have 2 electrons maximum. So, total 5 orbitals. So, 10 electrons maximum. Next. So, all these problems are revolving around those few formulas only. 3-4 formulas I have given, and within that only all these problems will revolve. Okay. How many maximum electrons possess spin quantum number? S means spin quantum number plus half or minus half. Plus or minus half, how many electrons can possess that? In an orbital, see, an orbital, that means single house they are talking, single house. So, in a single house we know only 2 electrons and one will have plus half spin value, other will have minus half. So, no matter which street or which subshell you are going, which shell number you are going, in an orbital maximum 2 electrons only, and one will have plus half, other will have minus half. So, maximum electrons therefore is 2 only, because in a orbital, an orbital, okay, I am mentioning again and again, single orbital, single house has only 2 electrons. Okay, this is the notation of clockwise spin, anti-clockwise spin. Clockwise spin notation is like this. This is an electron having clockwise spin. Anti-clockwise means like this, opposite. So, only 2 electrons will be present maximum within a orbital. That is why 2. Next, how many maximum electrons occupy in following subshells? Now, this time I have not given n is equal something, L is equal something, a different way I have given. See, 3D. 3D means what? 3D means n is equal 3. See, what is the number here? 3. N is equal 3. L is equal, I have mentioned earlier, L is equal to 0 means S, 1 means P, 2 means d orbital, 3 means f orbital. This is the alphabetical notations. Same way, d means what? L value 2. So they are saying indirectly, n is equal to 3, L is equal to 2. In that particular city and this in this street of that city, how many people or how many occupants will be there? Okay. So we know that in that particular street, how many will be there? 2L plus 1 orbitals will be there. So that means 2 into 2 plus 1, 5 orbitals. That means maximum electrons will be 2 into 5, 10 electrons. 3D has maximum 10 electrons. Next, 4F. Again, let's decode this 4F also. 4F means what? N is equal to 4, L is equal to this time 3. S 0, P means 1, D means 2, F means 3. So here number of orbitals will be what? 2L plus 1. Let's calculate by taking L value as 3. So 2 into 3 plus 1, 7 orbitals are present. So 7 orbitals means how many electrons? 7 into 2, 14 electrons are present. Okay. So first one answer is 10 electrons, second one answer is 14 electrons. Next, which of the following do not exist? Which of the following quantum numbers do not exist, not possible? Okay, let's figure that. Say n is equal to 4 given 0, fine, but is it right or wrong? We have to check. See, we know that earlier n value or shell number is connected to the subshell number. Number of subshells, or what is the subshell number, is decided by whom? Is decided by the shell number. Okay. How? See, L values or subshell number values begins with 0, ends with n minus 1. So shell number n is deciding what is the last L value of the subshell. Magnetic quantum number, that is dependent upon the L values. How? Their values begin with minus L, ends with plus L. That's why total values are 2L plus 1. Minus L up to 0 is L. Similarly, after 0 to L, again L. So 2L, and including that 0, total 2L plus 1 values. But beginning is what? Minus L, ending is plus L. Okay. Now, let's see. N is equal to 4. In that fourth shell, what are the subshells present? In that fourth shell, what are the subshell values? L value starts from 0 and L is equal to 0 will be there, L is equal to 1 will be there, L is equal to 2 will be there, L is equal to 3. Stop there. Don't go beyond that. Because what is the last value of L? N minus 1. That is the last value of L. N is here what? 4. That means 4 minus 1 is what? 3. So you start with 0 and end with 3. So there are only 4 subshells, or only 4 streets are present in this city. That is the meaning. Okay. Now, so but they are saying in the question what? L is equal to 4. So does it exist in this particular shell number? Does not exist, because L value 3 is the last. L is equal to 4, 5, 6 does not exist only in this particular shell number. That's why it does not exist. You need not go for other magnetic quantum number or this. If this is not existing, it failed automatically. Now come to the second case. N is equal to 3. If n is equal to 3, what are the L values? 0, start beginning is 0, 1. What is the last L value? 3 minus 1 is 2. So, this is the last. Yes, L is equal to 2 given. So, fine, there is no problem with this. Okay. Now, go to the next one. ML is equal to minus 3. In that particular subshell, does magnetic quantum number have value minus 3? We have to check. So, ML values begin with minus L and with plus L. Okay. So, minus L means what? L is equal to means minus L means what? Minus 2. So, ML values will be minus 2, then minus 1, 0, 1, 2. Only this is the magnetic quantum numbers possible within that subshell. L is equal to. But what they have given? Minus 3. Does it possible? Is it possible? Minus 3. See here, minus 3 is not there in this list. So, therefore, this is wrong here. In earlier, in the first question, L is equal to 4 is wrong. Here, this is wrong. That's why this quantum numbers again, this set of quantum numbers does not exist. So, this is also wrong therefore. Next, 1p. 1p means what? N is equal to 1 and L is equal to p means 1. Is it possible? N is equal to 1, L is equal to 1, is it possible? See, if n is equal to 1, L values begin with 0, end with n minus 1. N minus 1 is what? 1 minus 1 is 0. So, its beginning number and ending number is must be 0 only. So, there is no 1 possible here. Therefore, this is also incorrect. That is also not possible. 3p. 3p means what? N is equal to 3, L is equal to 1. Possible? Yes. Because n is equal to 3 means L values are what? 0, 1, 2. So, we have seen that here. N is equal to 3 means 0, 1, 2 possible values of L. And they have given P means L is equal to 1. Absolutely fine. So, this is correct. It exists. Okay. Does not exist. They are asking does not exist means I am putting cross mark. Cross mark means does not exist. Tick mark means exist. Okay. Understand. 2D. 2D means what? N is equal to 2. D orbital means L value will be what? In numbers wise, this is alphabet D. In numbers wise, L value is what? 2. And N is equal to 2. If N is equal to, L values will be what? 0 and 1. 1 is the last number. So, 2 is not possible only for that. So, this is also incorrect. So, this is how you have to identify. These are the different models are asked, which are asked in the NEET exams finally. One is which of the following quantum numbers does not exist. Okay. How many orbitals will be present within a subshell? How many orbitals are present within a shell? How many maximum electrons are present? These are the different models of the quantum number questions. So, this is very important in NEET exam. In atomic structure chapter, if you see the previous year's questions, many questions come from the quantum numbers topic. And it is not that difficult topic also. See, this year also simple question is only asked. Okay. How many, instead of asking how many orbitals are present within a subshell, they are asking if magnetic quantum number of magnetic quantum numbers is called Nm, is denoted as Nm, and what is the correct relationship in the given options. Okay. That means number of magnetic quantum numbers, that means number of orbitals is equal to formula is what? 2L plus 1. That only they have given, just modified one. Okay. So, simple things only you will get. I hope all these points you have understood. Okay. Anyway, once you come back, once you come to the normal physical classes, again this topic will be taught to you towards the end of atomic structure chapter. So, okay, thank you for listening to me. Okay. I will stop here. Okay, sorry, I thought class is still 6:30. Let me continue. Let me teach you few more points on this quantum numbers. Okay. Energy of orbitals. See, how to identify which orbital has more energy, which orbital has less energy. See, energy is proportional to the n plus L value. If n plus L value is more, energy of that orbital will be more. If that is less, energy will be less. You may get one doubt, sir, what happens if two orbitals have same n plus L value? If two orbitals have same n plus L value, then it is proportional to the n value. When we have to apply this relation? When n plus L value is same. Okay. But remember, this rule you have to apply when you are dealing with multi-electron atoms or ions. If more than one electron is present, we call such species as multi-electron species, more than one electron species. So these formulas are this relationship are applicable to multi-electron species. For multi-electron species. Multi-electron means what? More than one electron. Okay. Now, suppose there is only one electron present, for example, hydrogen. Hydrogen has how many electrons? Only one electron. Helium plus, helium cation has how many electrons? That also has one electron. Like that, if you are dealing with one electron species, then what to do? For single electron species, examples hydrogen, helium plus, lithium plus 2, like that, single electron presence. Then what to do? Then very simple, energy is just proportional to the n value. Don't go for n plus L this time, only n value will decide the energy. Higher n value, higher energy. Now let's see some problems on this. Okay. Find the order of energy of below given orbitals. Okay. So once I go to the previous page, first we have to see n plus L value. If n plus L value is same for two orbitals, then higher the n value, higher the energy. Okay. Now sometimes they don't mention in the question multi-electron species, single electron species, they don't mention these words. Then what to do? Remember, if they don't mention anything about number of electrons, by default assume that question belongs to the multi-electron and answer the question. Okay, if they don't mention. Now see, if they are saying find the order of energy of below given orbitals, they are not mentioning single electron or multi-electron. So now therefore take it as multi-electron, assume multi-electron and answer the question. Now see, 2s. 2s means what is the n value? N value is 2. S means L value 0. N value 3. P means L value is 1. I mentioned S is 0. P means 1. D means L value 2. F means L value 3. So N is equal to 3, L is equal to 1. 4s means what? N is equal to 4. S means L is equal to 0. Next 3D. 3D means N is equal to 3. and d orbital. D orbital means what L value? L value is 2. 4p. 4p, 4. 4 means N is 4. P. L value of P is what? 1. Now, let's add this N plus L values and figure out which is high, which is less. N plus L value is what? 2 plus 0 is 2. 3 plus 1, 4. 4 plus 0, 4. 3 plus 2, 5. 4 plus 1, 5. So, these are the N plus L values. Now, here first according to N plus L values, let us see which is higher energy, which is lower energy. Okay. Now, which is the highest value? 5 is highest. So, let us put 3D, 4P higher than the others. Among others, which is the higher number? 4 is higher. So, 3P, 4S. This is the next. And after that, below that, what is the lowest? 2S is the lowest. 2S is the lowest. Okay. Now, among this 3P and 4S, next doubt will come, which is the higher energy, which is the lower energy, because they both have same N plus L values. When N plus L value is same, higher the N value, higher the energy. So, among 3P and 4S, which one has higher N value? Higher N value is for 4S. Therefore, among 3P and 4S, 3P is less than 4S. And among 3D and 4P, again follow the same way. 3D has N value 3, 4P has N value 4. So, 4 is greater than 3. So, 3D less than 4P. This is the order of energies here. Okay. Now, same way let us figure out here. Here directly NL values are given. Directly take N plus L and figure out. See, N plus L. N plus L value will be what? 3 plus 2, 5. Here N plus L value is what? 2 plus 1, which is 3. Here N plus L value, N is 4, L is 1. So, 4 plus 1, 5. N is 3, L is 1. So, 3 plus 1, 4. Okay. There are two having same N plus L value. So, which is the higher energy? Here N is equal to 3, here N is equal to 4. 4 is bigger than 3. Therefore, this 5 is higher energy than, this related orbital is higher energy compared to the other orbital, okay, other subshell. Okay. Now, let us put them in order. Therefore, lowest is what? 3. N plus L value lowest is this. That means, let us call it as A, B, C, D. So, which is the lowest? B is the lowest. Then comes what? D. Next, AC konjam taggincham. Next, A and C. Among A and C, which is the next? Both have same, but among them N value is small for first one. So, A, then comes C. This is the order. Next, Aufbau, Hund's rule and Pauli's rule. See, these three principles or rules will help you in writing the electronic configurations. Okay. Now, what are these three rules? Let's go one by one. First, Aufbau principle or Aufbau rule we take. This rule says that when you are filling electrons in various orbitals within an atom, first lowest energy orbital you complete it, then only go for the higher energy. Without completing the lower energy orbital, do not begin the filling of electrons in the higher orbital. That is the rule. Okay. So I am writing here first. Fill electrons in lower energy orbitals before filling in higher energy orbitals. Lower energy orbital before filling in higher energy orbital. Means what? For example, if I have 1s, 2s, 2p, like this are their orbitals. Okay. Now, suppose if I have an electron, let's take one electron as of now. Okay. Or 3 electrons are there. Okay. Or first we will take one electron and we will understand that. If there is a one electron, then where you have to go, which orbital you have to go? 1s, 2s, 2p. See, among them, see 1s is like first shell, and in that s subshell. 2s means what? First shell, second shell, in that s subshell. 2p means what? Second shell, in that p subshell. Okay, of course, in that subshell orbitals or magnetic quantum numbers will be present, but this is the shells. Okay, which is the lowest energy among them? Lowest energy will be 1s. 1s is the lowest. 2s, because n plus l value we know the order. Okay, n plus l value accordingly if you take, and this is the order. 1s is less than 2s. Now, if you have an electron, one electron, where you have to fill? You have to fill in 2p, 2s or 1s. Since 1s is lowest energy, you have to fill electron in the 1s. Don't go for the 2s. Suppose if you have 2 electrons, then what to do? Say I am drawing here. Let's say this is 1s. 1s has how many houses? 2 into L plus 1, 2 into 0 plus 1, if you take only one house in the 1s subshell. Similarly, 2s subshell. 2s subshell means what? Again L is equal to what? N is equal to 2, L is equal to S means L value is what? 0. If L is 0, how many houses or orbitals present in that subshell? 2L plus 1. That is 1 only. Only one orbital present. Now, if only one electron present, we will put it in the lowest energy 1s. Suppose 2 electrons are present. Okay, in an atom 2 electrons are present. Then what to do? Again 1. Don't go like this. If 2 electrons are present, don't say, sir, I will put 1 electron in 1s, second electron in 2s. No, it is a violation of Aufbau rule. He is saying that before filling the higher energy, first fill the lower energy. If there is a vacancy in lower energy, you have to complete that first. Okay, that is the rule. So 1s orbital in this house, any house, maximum how many electrons? 2. So there is a vacancy for one electron, right? So before completing that, you are not allowed to go for the higher energy orbital. So therefore this is wrong. Then what is right, sir? How to fill? What is the right way? Right way is, I am drawing left side and I hope you understand. I will to use another color. 1s, 2s. So in that 1s, 2s, one electron you fill in the 1s and second electron also you have to fill in the 1s only. Okay, so two electrons, both electrons should be present in which orbital? 1s orbital only. Okay, don't go for the 2s. Lowest energy you have to complete it first. Okay, if three electrons are there, then third electron you don't put it in the because maximum how many electrons will fill in an orbital? Only 2. So third electron we should not put it in the first one, 1s, because 1s is completely filled now. There is no vacancy for third electron. Now go to the higher energy. Now among all the higher energy orbitals, 2s, 2p, 3s, 3d, etc., among them again select the lowest energy and fill that extra third electron in there. So next energy level is 2s, so we will fill there. Okay, like that. This is the way you have to fill electrons using Aufbau principle. Now, when you are filling electrons, what order we will see energy wise? 1s means n is equal to 1, L is equal to 0, that is the lowest energy out of all. Next comes 2s, n is equal to L is equal to 0. This is the next. Third is 2p. After that comes 3s. Okay, you can use n plus L value and see. You yourself will figure out which is the lower energy, which is the higher energy. But this order, okay, it is better to remember because many times we will come across, we have to fill electrons in an atoms. To write electronic configuration we need to know. So if every time if you calculate n plus L and see which is low energy, which is higher energy, it takes lot of time. Okay, just remember that rule, but some minimum order you have to remember, at least to write the configurations of simple elements. Okay, 1s, 2s, 2p, 3s, then after that next is 3p. After that next is 4s, next 3d. Up to this point sufficient. Okay, the other after that you need not remember at least at this level. Now, I mean, see n plus L value, let's calculate and see whether it is right order or not. Okay, here n plus L value is what? 1 plus 0, which is 1, 2 plus 0, 2, 2 plus 1, 3, 3, p means 1, so 4. So both are 4, but higher the n value, higher the energy. Both are 3, but higher the n value, higher the energy. So this is the order of energies. Okay. So but remember this order of in terms of 1s, 2s, 2p like that, because many times you have to apply that. That's why. Okay. This is what Aufbau principle, and similarly we see what is Hund's rule. Now Hund's rule says that, now Aufbau rule is dealing with first fill the lower energy, then go to the higher energy orbitals. Now Hund's rule deals with, suppose in a subshell there are many houses are there, many orbitals are there. How to fill electrons among them? That is being dealt by the Hund. So Hund's rule says that within a subshell fill all the orbitals, because what is there within a subshell? Within a subshell, houses will be there, or within a street, houses will be there. This we call orbitals. So within a subshell, orbitals will be there. How to fill among them? Fill all the orbitals with one electron each, having same spin before beginning pairing of electrons. This is the rule. Means what? See, suppose if I take 2p subshell, n is equal to 2, L is equal to 1. P means L is equal to 1. So this is a subshell. In this subshell, how many ml values will be there? See, n is equal to 2, L is equal to what? 1. So ml value starts from minus L to plus L. So minus 1, 0, 1. That means there are 3 houses or 3 orbitals present in this subshell called 2p subshell. Okay. So let's draw the figure. Let's say these are the 3 houses or orbitals, all present in the p subshell of second shell. So all are 2p only. But these 3 orbitals, now each of these 3 orbitals have n value 2, L value 1. So n plus L value and n value same only. Therefore, all these 3 within orbitals within a subshell have same energy, equal in energy. So within a subshell, fill all the orbitals with 1 electron each. That means Hund's rule is applicable for the same energy orbitals. If energy of orbitals is same, how we are dealing? How we have to deal? If energy of orbitals is different, simple. First lower energy you have to fill, higher energy you have to fill. Aufbau said very simple thing. But when energy is same for orbitals, which happens for orbitals within a subshell, then what to do? Then this rule is given by the Hund's rule, what to do. So here see, all have same energy. Now 1 electron you have to fill in each one having same spin. Okay. Suppose I have 3 electrons, fill like this, 3 electrons, same spin. Or you can fill like this also, opposite spin, anti-clockwise spin you can choose, or clockwise, it is as you wish, but same spin you have to maintain, and fill each orbital with 1 electron only. Okay. So this is also right, this is also right. Suppose if you draw like this, 3 electrons, 1, okay, look here, 1, 2, 3. You are putting 1 electron each. That is fine. But are you maintaining same spin? No. So this is wrong. And similarly, suppose if you take one like this, 3 electrons I am filling. That is also wrong, because you are actually not filling each orbital with 1 electron. You immediately started pairing the electrons. First what you have to do, you have to put 1 electron in each of these orbitals, equal energy orbitals. Each one you put 1 electron. Then only think about the pairing. But we have already paired before having 1 electron in each orbital. So this is also wrong. That is what Hund's rule is saying. Equal energy orbitals, if you are dealing, put 1 electron in each one. Next, Pauli's rule. Let's see the Pauli's rule also quickly. Pauli's principle says, it's very simple. Pauli's principle says, maximum 2 electrons will be present in the any orbital. This we have seen already previously also, okay, but that is actually given by the Pauli. Maximum how many will be there in an orbital? Any orbital, maximum 2, and both will have opposite spin. Both will have opposite spin. Maximum 2 electrons occupy in any orbital and these 2 electrons must have opposite spin. Clockwise spin, other one has to be then anti-clockwise. Both clockwise not correct, both anti-clockwise also not correct. 1 electron can be present. Maximum how many occupy in any orbital? 2, not more than 2. But these 2 must have clockwise and anti-clockwise. So that is the thing. Now let's see one question and I will close this topic. Suppose if I give 1s, 2s, 2p. Now if I ask a question, which rule is violated? Aufbau rule, Hund's rule or Pauli's rule, or a combination of them? Then see first. See, 1s is completely filled, fine. Both have opposite spin, fine. Now go to the 2s. 2s has one vacancy is there. Before completing that, you have gone to the higher energy 2p case, 2p orbitals. So without completing the lower energy, 2p we went. That means it is a violation of which rule? Aufbau rule. So Aufbau is violated. Okay, A violated means understand it is Aufbau is violated. Okay, Aufbau rule is violated. Next, let's see Hund's rule, whether it is violated or not. See here clockwise spin 1 electron, anti-clockwise 1 electron, anti-clockwise is there. See here clockwise, here also if they put clockwise then fine. Every orbital of same energy, 1 electron with same spin, then it is a Hund's rule. But here it is clockwise but anti-clockwise is there, which is wrong. Therefore violation of Hund's rule, H is also violated. Finally, Pauli's rule. Pauli says what? 2 electrons maximum in an orbital. Fine, 2 electrons. Here 1 is fine, maximum 2 he said. So less than 2, 1 electron or 0 electrons is also fine. There is no problem with Pauli's with that. 2 electrons are there, fine. But he also said those 2 electrons must have opposite spin. But here both have same spin. 2 electrons, but they have same spin. So Pauli's is also violated. That's it. So having this knowledge of 3 rules, Pauli's, Hund's rule and Aufbau rule, then we can easily write the electronic configurations. Hydrogen, helium, lithium, like that, any element electronic configuration. By following these 3 rules, we can write easily. Okay. So I'll stop here. Due to lack of time, I cannot teach more than this. But using this, how we can write the electronic configuration, that you will learn later on. Okay. I'll stop here. Thank you.